Hello and welcome to our new course on design wind pressures on a steel structure warehouse. In this course, I will explain the full and detailed process of calculating the design wind pressures for structural members and cladding surfaces of the walls and roof of a steel frame warehouse. The assessment of wind loads for the design of structures is based on Australia and New Zealand standard AS 1170.2. However, the general concept remains the same for every other code. AS 1170 has a very detailed and comprehensive process for calculating wind pressures. There are so many parameters and requirements in the code, which often leaves people with some confusions and question marks on how to approach this. So I have decided to prepare this course to provide a clear roadmap for anyone who wants to learn the process step by step. I am a professional engineer working in Australia with more than 7 years of experience and have a solid knowledge of design and analysis of steel structures, reinforced concrete, post-tension concrete, composite systems, and masonry structures in accordance with Australian and international standards. I have worked on a range of projects, including buildings, stadiums, metro and train stations, rail structures, and airports. I also have a PhD in structural engineering, and because of my passion for education and teaching, I have also worked as a university lecturer in the past. I'm committed to provide content that can fill the gap between academia and industry by providing the practical courses. For this reason, I have created this course to give you the skills required to calculate design wind pressures for a steel frame warehouse and make you familiar with the fundamentals of the design within a full and detailed real-life example. This course, Design Wind Pressures on a Steel Structure Warehouse, includes two parts. In the first part of the course, you will learn about the basics and general concepts of wind loading on structures within our practical and real-life example. I will also explain about how to calculate wind parameters and where in the code I'm getting these values from. These wind parameters include regional wind speed for different areas of the country, train or height multiplier and explaining the definition of different train categories, defining importance level of buildings and return period of the wind event, considering the occupancy and use of the building, wind direction multiplier, hill shape and shielding multipliers, site wind speed, and design wind speed. I will also explain about aerodynamic shape factor for different surfaces or parts of the building. Calculating aerodynamic shape factor requires calculating the external and internal pressure coefficients, area reduction factor, local pressure factor, action combination factor, permeable cladding factor, and dynamic response factor. These factors has to be determined for windward walls, leeward walls, side walls, roof structure, and cladding surfaces of the wall and roof with respect to the wind on 4 major axes of the structure. And then we will calculate design wind pressures on structural elements of the walls and roof for different portal frames of this warehouse. We will also check frictional drag forces on roof and side walls, and will explain how wind pressure changes along the roof or the long walls. In the second part of the course, you will learn about Design wind pressure on doors and windows and how the size of opening can impact the net pressure on walls and roof surfaces. Design wind pressure on wall claddings and supporting structures and how to calculate localized wind pressures on wall claddings. Design wind pressure on roof claddings and supporting structures and how to calculate localized wind pressures on roof claddings. Evaluating the impact of big openings on internal and net wind pressure on cladding surfaces of the roof and walls. How wind pressure changes along the roof and long walls. And finally, you'll see the summary of the net wind pressure on different areas of the roof. This course is beneficial for structural engineers ranging from beginners to intermediate level who would like to refresh their knowledge and get a practical knowledge of wind loading on structures. Also, graduate engineers, structural engineering students, and civil engineering students can benefit from this course. By the end of this course, you will learn about the fundamentals and detailed process of calculating the wind pressures for structural members and cladding surfaces of the walls and roofs of the steel frame warehouse. My goal is to add value to my students by conveying my professional and practical experience, as well as explaining the theoretical concept behind the design. So please do not hesitate to ask if you have any questions through the message box here or any other social media links which are provided in our page. Also, you will have lifetime access to the course content, which means you will receive all the future updates and additions free of charge. Thanks for watching and hope to see you inside the course.